Okay, boys and girls, welcome to our fourth video lesson in Chapter 11, our lesson on the area of regular polygons. And let's remember that regular polygons are polygons where all sides and all angles are congruent. All right, here we go. Okay, area of a regular polygon, and as we just mentioned, all interior angles and all sides are congruent in a regular polygon. Okay, as we look here, we have a circle that's circumscribed around about this hexagon. I have a regular hexagon, right here. I also have an equilateral triangle right here, and just so you know, there are 6 equilateral triangles in any regular hexagon. 1, 2, 3, 4, 5, 6. Keep that in mind. That will be helpful. Okay, the measure of a central angle in a regular polygon is going to be the measure of this angle right here. That is a central angle. It is the angle formed when we go from the center of our polygon, draw 2 lines, 2 vertices of our regular polygon. And in this case, because I have a hexagon, I'm going to have 6, as I just said, we have 6 triangles. So I'm going to have 1, 2, 3, 4, 5, 6 equal angles. So I'm going to take 360 and divide by, in this case, 6, or by n, the number of sides in our polygon, to get the measure of each central angle in a regular polygon. So the formula for the central angle of a regular polygon is 360 divided by n being the number of sides. A couple more words you need to know. The center of a regular polygon would be the center of a circle that's circumscribed about the polygon. So this is a regular pentagon because I have 5 sides. This circle right here, centered at x, is circumscribed about my regular pentagon. So point x is my center of my polygon. Okay, the radius of a polygon is any segment drawn from the center to any of the vertices. It's also the radius of the circumscribed circle. So XR would be an example of a radius. An apothem, or an apothem, is a segment drawn from the center to the midpoint of any side of a regular polygon. So in this case, our apothem is XN. And of course, we just talked about the central angle. The central angle is going to be this guy right here. I'll do that in green. That's my central angle. So my central angle in this case is angle QXR. And because it's a pentagon, there are 5 central angles. Okay? And the measure of any of those angles, we just did this, is going to be 360 divided by n, and in this case is 5 because it's a pentagon. So each of those angles is 360 divided by 5, which is 72. So, find the area of a regular polygon. There is a formula, and I will derive this for you in class, but the area of a regular polygon is 1/2 A, meaning an apothem, times P, the perimeter of our regular polygon. So the area of any regular polygon is 1/2 AP, where A is the apothem and P is the perimeter. So let's do this problem right here. We have the top of the table shown as a regular hexagon with a side length of 3 and an apothem of 1.7 feet. What's the area of the tabletop? So I know now that I'm going to do area is equal to 1/2 A, meaning apothem, times P, meaning perimeter. So area equals 1/2 times my apothem, which is 1.7, times my perimeter, and my perimeter is going to be 3 on each side, and I have 6 sides, so 3 times 6 is 18. So I'm now going to whip out my little mini calc. Maybe you heard that. So I'm going to do 0.5 times 1.7 times 18, and I get an area of 15.3. Okay, I'm going to give you one more formula here. The area of an equilateral triangle is always s squared root 3 all divided by 4. S squared, where s is the length of the side, times root 3 divided by 4. You know I'm not very big on memorizing a lot of formulas. I will derive this with you in class. It's actually pretty cool. But you need to either memorize that, or just you have to rederive the area each time. But let's use our formula right now to find the area of this regular triangle, an equilateral triangle. Area equals s squared root 3 all divided by 4, and my side is 12. So my area is equal to 12 squared root 3 all divided by 4. I'm going to pretend for a minute I don't have a calc, so I'm going to do 12 times root 3 all divided by 4, and now I'm going to cancel my 4 with one of my 12s and get 3. 3 times 12 is 36, and I still have my root 3 kicking on there to the side. So my area is going to be 36 root 3. Find the area of a regular hexagon. Well, there's two steps here. If I know my side is 8. First thing we have to do is find the apothem. So I now know, I'm going to draw this in blue. I have an equilateral triangle right here in blue. Each side with a side of 8. I have two options here. I certainly could find the area of that one equilateral triangle using s squared root 3 divided by 4, and then multiply by 6, because I'm going to have 6 of those things. Or I can use my 1/2 AP, and we're going to do it that way. So I'm going to just think about right here. I have a 36, 60, 90 triangle right here. I'll do this in red so you can see it. Well, if this total side here is 8, means all these sides are 8, right? Which means this little piece here is 4, which means now my apothem is 4 root 3. Okay, so now I can find the area of my hexagon using the area equals 1/2 AP formula. 1/2 is 1/2. My apothem is 4 root 3. And my perimeter is 8 times 6 sides. My perimeter is 8 times 6, which is 48. So now let's do some multiplication. 1/2 of 4 is 2. 2 times 48 is 96, and I still have my root 3 kicking around right there. So it's 96 root 3, and there's my final answer. Find the area of regular pentagon with a radius of 5. Whenever we're dealing with a regular polygon such as a triangle, a square, or a hexagon, we can do that without trig. Now though, whenever we have any other regular pentagon, we need to do this with trig. Okay? And I'm going to do this with you in class because this is, a couple of steps. But once you see it and once you understand it, it's really not that bad. First thing I'm going to do is I'm going to draw on a isosceles triangle. I'm going to have 5 of these guys because it's a pentagon. All these isosceles triangles are equal. I'm now going to find the measure of my central angle while using my formula. I know it's 360 divided by 5, which of course is 72. Now what I'm going to do is I'm going to erase for a minute, and I'm going to think about taking my isosceles triangle, which I have, and I'll draw that in blue. Here's my isosceles triangle. I know that this angle right here is 72, so what I'm going to do here in green, I'm going to chop that angle in half and draw a right triangle right there. So I have a right triangle right here in green, where this angle right here in green is going to be half of 72, so this angle right here is 36. Now I'm going to use some trig, and I want to find my apothem, which I'm going to call x. So I now know that cosine of 36 degrees is equal to my adjacent side, that's this blue length right here, x, over my hypotenuse, which is this long side right here, that's 5. So I now know that x, or my apothem, is equal to 5 times cosine of 36. So hold on a minute. Okay, using my calculator, I found that x, or my apothem, is equal to 4.045. Let's call it 4.05 if I round. It's right smack dab there in the middle. We'll call it 4.05. Okay, and now what I need to do is I need to use my formula. Area is equal to 1/2 AP. Well, you can see now still that we're missing our perimeter, so we need to use trig again. So I'm going to set this up now. I'm looking for, let's call in red, let's call this thing, we'll call this y. I do know that the sine of 36 is equal to y over 5. That's opposite over hypotenuse. So whipping out my calculator, I know that y is going to equal 5 times sine of 36. So I got 5 times sine 36 is equal to, let's call that 2.94. So this guy right here in red is 2.94. So my perimeter is going to equal 2.94 times 2 is going to be one side. And then I got to take that and multiply by 5 more because I have 5 sides. So in essence, it's 2.94 times 10. So we'll call my perimeter 29.4. So my area is going to equal 1/2 times my apothem, which was 4.05, times my perimeter, which is 29.4. Whip out your calcs, and you should find that our area now is equal to, let me get a different color so you can see it, we'll do it in green, is 59.5-ish. And there's my area of my regular hexagon. I'm sorry, that was a pentagon, regular pentagon. One more. Find the area of the regular pentagon. This time we have a radius of 9. So once again, we're going to do this in a number of steps. First thing I'm going to do is figure out the measure of my central angle. Well, I know it's 360 divided by 5, which is 72. So that's the measure of this angle right here, which means now in blue or in green, so we can see it, half of that angle is going to equal, so times 1/2, is going to equal 36. So this angle in green is 36. So now I need to find two lengths. I need to find my apothem, which is going to be this length right here in red. I'm going to use cosine to do that. I need to find half of my side, which is that green length right there, and that I'm going to use sine to do that. So I know, let's call the red x. Let's call the green y. So I now know that this cosine of 36 degrees is equal to x over 9. I also know, in blue here, the sine of 36, that's a 6, is equal to y over 9. So therefore, x is equal to cosine of 36 times 9, and y is equal to the sine of 36 times 9. This, of course, is equal to my apothem, and this, of course, is equal to 1/2 of my sine. So if I multiply 1/2 on my side by 2, I get one side. And multiply that by 5, I get my perimeter. So if I take that whole thing and multiply by 10, I get my perimeter. So my area is equal to 1/2 my apothem. Hold on, let me do the math with my handy dandy calc. I got cosine 36 times 9, and I get 7.28 times my perimeter, which is sine of 36 times 9 times 10. My perimeter is 52.9. If I multiply all of those out, I'm going to get my area, which is 52.9 times 7.28 times 1/2. And I should have an area of 192.56. And there it is.